This is SpaceTime, Series 25, Episode 19, for broadcast on the 14th of February 2022. Coming up on SpaceTime, discovery of a free-floating black hole hiding in plain sight. A new planet discovered orbiting around our nearest neighbouring star, Proxima Centauri. And evidence of an extinction-level impact event on Mars. All that and more coming up on SpaceTime.
Welcome to Space Time with Stuart Gary.
Astronomers have found evidence of black holes floating undetected through the darkness of interstellar space. Black holes themselves can't be seen because their gravitational pull is so strong that nothing, not even light, can escape. So the only way scientists can detect the existence of a black hole is by their gravitational influence on surrounding bodies, changing their orbits or tearing them apart if they venture too close. But a black hole floating alone in space with nothing around it would be invisible, at least until you get too close and it's too late. The only possible way of detecting such an object would be by the gravitational microlensing effect it would have as it passed in front of a background star, bending its light. Now, a report on the pre-press physics website archive.org has confirmed just such an event, originally witnessed back in 2011. Stellar mass black holes are formed through the collapse of massive stars at the end of their lives or through the merger of two stars. And there's growing evidence from gravitational wave observatories that these sort of events are common. So, based on these facts, astronomers have long assumed that a large population of stellar mass black holes must be out there wandering through the darkness of space. But until now, none have actually been found. And given the great distances, the lensing effect of a free-floating black hole as it transited in front of a background star would be very slight, making it nearly impossible to detect. However, astronomers detected just such an event back in 2011 when they noticed a distant star suddenly appear to brighten for no apparent reason. Now analysing data from the Hubble Space Telescope has allowed scientists to study the changes in the light from this star in more detail. And not only did the star appear to brighten, but also the position of the star appeared to change as well. And that could only have been caused by a very massive but unseen object passing in front of it, causing its light to be lensed. Now, based on the degree of lensing, this object must have had about 7 times the mass of our Sun. And yet it was invisible. And that sort of limits it to being, well, a black hole, exerting a force that was pulling on the light as it passed by, travelling at around 45 kilometres per second. And that's a neat bit of astronomical detective work. This is SpaceTime. Still to come, a new planet detected orbiting around the star Proxima Centauri, and an extinction-level asteroid impact on Mars. All that and more still to come on SpaceTime. A third planet has been discovered orbiting in our nearest neighbouring star system, Proxima Centauri. The new planetary candidate, named Proxima d, is only about a quarter the mass of the Earth. The discovery, reported in the journal Astronomy and Astrophysics, was identified by astronomers using the European Southern Observatory's Very Large Telescope, or VLT, located in Chile. Proxima d orbits around Proxima Centauri at a distance of just 4 million kilometres, less than a tenth the distance of Mercury's orbit around the Sun. In fact, it's so close in to Proxima Centauri that it's orbiting between the star and its habitable zone, the area around a star where it's not too hot and not too cold, but just right for liquid water to exist on a planet's surface. Each orbit of Proxima d around its red dwarf host takes approximately 5 Earth days. Proxima Centauri is already known to host at least 2 other planets. There's Proxima b, a planet with a mass similar to that of the Earth, which orbits in the star's habitable zone, taking 11 days to complete each orbit. And there's Proxima C, which is further out, taking about 5 Earth years to complete an orbit around the star. Evidence for Proxima D first came up a few years ago by astronomers using the HARPS instrument on the European Southern Observatory's 3.6-metre telescope. It was confirmed in 2020 using the espresso spectrograph on the VLT, which showed that it had a 5-day orbit around its host star. At just a quarter the mass of the Earth, Proxima D is the lightest exoplanet ever measured using the radial velocity technique or wobble method, surpassing a planet recently discovered in the L9859 planetary system. The wobble method works by picking up tiny wobbles in the motion of a star created by an orbiting planet's gravitational pull on that star. Although imperceptible visually, that wobble can be picked up as a slight Doppler shift in spectroscopic readings. Still, the effect of Proxima D's gravity is so small, it only causes Proxima Centauri to move back and forth by around 40 centimetres per second. That's about 1.44 kilometres an hour. Proxima Centauri is our nearest neighbouring star. It's located approximately 4.25 light-years away and is part of the Alpha Centauri triple star system. The other 2 stars in the system are Alpha Centauri A and B, which orbit each other. Proxima Centauri orbits the pair a bit further out. The star is a spectral type M red dwarf. It's only loosely gravitationally bound to Alpha Centauri A and B, orbiting the pair at an average distance of 13,000 astronomical units, or about 0.21 light-years. That's about 430 times the size of Neptune's orbit around the Sun. Proxima Centauri takes about 550,000 Earth years to complete each orbit around Alpha Centauri A and B. This is SpaceTime. Still to come, evidence of an extinction-level asteroid impact event on the red planet Mars, and a new study suggests that ancient giant supermountain ranges may have helped the evolution of life on Earth. All that and more still to come on SpaceTime. Scientists have found evidence for an extinction-level asteroid impact event on the red planet Mars dating back almost 4.5 billion years. The discovery, reported in the journal Science Advances, opens a new window into the sorts of conditions life on ancient Mars, if it ever existed there, would have had to endure. The evidence was found in a zircon from the famous Mars meteorite known as MWA 7034 and colloquially referred to as Black Beauty. The 320-gram space rock was found in northern Africa in 2013. The meteorite is actually a collection of broken rock fragments and minerals, mostly basalt, that solidified together over time, forming regolith breccia. The zircon found inside the meteorite showed evidence of high-intensity shock damage, the type that only occurs during really massive asteroid impacts. This sort of high-pressure shock deformation hadn't previously been found in any minerals from Black Beauty. One of the great features of zircons is their ability to act as geological calendars, marking the exact moment they formed over cosmic timescales. And in the case of this zircon, the uranium to lead radioactive dating indicates the collision which formed the zircon took place some 4.45 billion years ago. And we know from the high-pressure shock deformation that the impact was as big as the KT boundary event asteroid impact on Earth 66 million years ago. The KT boundary event impact on Mexico's Yucatan Peninsula triggered a mass extinction event which wiped out 75% of all life on Earth, including all the non-avian dinosaurs. One of the study's authors, Dr. Erin Cavosi from Curtin University, says the occurrence of zircon grains in the Black Beauty meteorite provides physical evidence of large impacts on early Mars and has implications for the habitability of the young planet. He says the type of shock damage in this Martian zircon involves a process called twinning, which has been reported from all the biggest asteroid impact sites on Earth as well as the Moon, but not previously from Mars. Cavosi says previous studies of zircons in Mars meteorites propose that conditions suitable for life could have existed 4.2 billion years ago. That's based on the absence of definitive shock damage. But this impact event was on a scale known to cause mass extinctions on Earth. So the zircon means the habitability window on Mars may have occurred much later than previously thought, perhaps coinciding with the liquid water on the red planet between 3.9 and 3.7 billion years ago.
Of all of the different meteorites that have been identified as originating from Mars, Black Beauty is just an entirely different story than all the others. The last time I checked, there were some 60 or 70 or 80 meteorites out of the world's collection of 60 or 70,000 meteorites that have been found to have originated from Mars. The majority of those are igneous rocks, and so most are common basalt or basaltic-like volcanic rocks. Not all of them, but most of them are. But Black Beauty is very different. It's an actual piece of the surface, and the surface of Mars is a funny material that's called regolith. And regolith has probably more been used in a planetary context for talking about the surface of the moon. When the astronauts from Apollo set foot on the moon, they were walking around in kind of a fluffy, powdery mixture of mostly broken up rocks and minerals that had accumulated on the surface of the moon for quite literally billions of years as a consequence of the moon being subject to lots of impacts that just continually stirred up and broke apart and mixed this material together. Every time a big impact happened. Yeah. Every time an impact happened, this stuff would get remobilized and fall back down into place and even more mixed. That's lunar regolith. And the name people have given to Black Beauty is a regolith breccia. And so it's basically fragments of broken rocks and minerals, potentially housing dozens, if not hundreds, of different kinds of rocks that accumulated on the surface of Mars and over time became solidified into a rock. So it's quite different.
So with something as unique as this, it must be giving astronomers, geologists, scientists generally, I guess, a chance to understand a little bit more about what Mars was like.
Yeah. Well, there's the thing about Black Beauty that's fascinating and a little bit confusing at the same time is we're talking about a history book where there's probably been several different impacts that are known and maybe even some that are not known. And here's what I mean by that. The impact event that knocked off what we call Black Beauty is rather young. That's probably happened somewhere in the last 5 or 10 million years ago. So it was a relatively recent impact on the surface of Mars that knocked off enough material at a velocity that was able to leave the orbit of Mars and ultimately got on a path that crossed the orbit of Earth. And some of that fell. It made it through Earth's atmosphere and landed as an intact rock. The original Black Beauty stone is only a little over 300 grams, so it's not that large of a rock, to be honest. But that was the most recent impact event that affected that rock. If you go back in time of Black Beauty's history, parts of the history are better known than others, but prior studies have found a relatively low-level intensity of damage across the Black Beauty meteorite, and they attribute that low-level shock intensity to the blast that ejected it, the launch event, as it's called. The kind of history that we found is very different than that, and there's some reasons that we think so. For one, the low-level shock intensity affected all the minerals across Black Beauty, and so most of those are grains of common minerals that are called pyroxenes and feldspars. And when you examine them throughout the meteorite, they all have kind of fractured appearances and some other phenomena that are attributed to a low level of shock intensity. And since that effect is present throughout the Black Beauty meteorite, it's attributed to have the whole meteorite has experienced that, and that's attributed to getting Black Beauty off the surface of Mars. So that's the recent damage. The thing we found is different. It is an event that is recorded in zircon. And for starters, the mineral zircon requires a higher background level of shock deformation to form such features. And we can talk more about what those features are in a minute if you like. But the significance of the find is we surveyed quite a few zircons in Black Beauty, over 60, and only one of them preserved this shock damage, as we call it. And the first observation around that is that if the meteorite was intact when it felt that history, more of the zircons would express that kind of feature. But that's not what we found, and that led us to the rationalization that whatever this zircon felt, it felt it somewhere else prior to being incorporated in the material on the surface of Mars that ultimately solidified to become this meteorite called Black Beauty. And so we're looking at something that happened, we think, long before the material even was put together on the surface of Mars. And so it's a pre-meteorite and even pre-deposit history that is recorded in this grain.
Is this what's called twinning?
The microscopic damage we found is called twinning. And twinning is a relatively common process in lots of minerals, but not this kind of twinning. Lots of minerals on Earth and in mineral collections are gorgeous examples of minerals that grow together. What occurs when a twin happens is that there's a plane of atoms on the crystal lattice. You can think of a lattice as kind of the house in a crystal where all the atoms sit. And it's sort of like if you build an addition on your house. You have one crystal growing in one direction and the exact same mineral that shares a wall, in this case, the crystal lattice, but it grows in a different direction. And so that's a twin. And they often form during the growth of minerals, not under impact conditions. And there's, again, beautiful examples in mineral collections and museums of this phenomena. The difference in a deformation twin is the way it looks and its size and its appearance are far different. And we can recognize the deformation twins when they form in zircon because they're kind of like thin plates. If zircon is small enough itself, it is about the width of a human hair when it forms in a magma. And so zircon's an infinitely small mineral, but the twins that form in it are even much smaller. They're only about 1 micrometer across, which is a fraction of the size of the whole crystal. So we're talking about a mineral that's the width of a human hair, and we're forming a very thin twin inside that mineral. And typically there are many of them, and that's what's shown in our papers, that evidence of these twins. And so really what's happening when you make a deformation twin is the pressures are so high that they're causing the atoms to reorganize and form a new bit of zircon, a twinned zircon, that shares one common connection to the main crystal that felt the shock wave. But then the twin grows in a different direction. For us, we can easily detect the presence of that twin with our scanning electron microscopy methods. And so it wasn't a question of whether this was a solid result or not. This was a bulletproof result. As soon as we saw it, we knew what we had.
So we're talking here about a piece of regolith that was on Mars. It got hit once and then it got hit again many millions of years later?
Well, that's just it. We proposed that this event that formed the shock zircon occurred before the regolith that we call Black Beauty was incorporated together. Because if the regolith as Black Beauty looks today, if that zircon formed the shock feature inside of it, we would expect more zircons in Black Beauty to reflect that process. So our argument was we surveyed quite a few zircons and we only found one that has this feature. Therefore, the event that did it occurred before all this material came together. And so we're looking at something that's early in the history of Mars.
Were you able to date the zircon, which can often be done looking at the radioactive decay of uranium into lead?
It sounds like you're spot on. Zircon is one of the best, what we call geochronometers, that is known in geology. And this is because it incorporates just a sniff of uranium when it forms, and over time that uranium decays to lead, and there's typically no lead in zircon when it forms. So it's a matter of using mass spectrometry to count the atoms of lead and count the atoms of uranium and determine the time that it took to establish that isotopic clock. In this case, it was relatively straightforward to do that, and we got an age for when that zircon formed as a magma or from a magma of 4.45 billion years. And there's a lot of things around that number. For one, that is older than any zircon known from Earth. And so the presence of zircons in Black Beauty, some of them are older than any intact piece of Earth that's ever been identified. That's pretty amazing, actually. We weren't the first ones to find zircons this old. There is an ancient population of zircons in the Black Beauty meteorite that date from between about 4.48 billion and 4.43 billion. And if you don't normally think about billions and all those decimals, it's basically about a 50 million year window of time that these zircons crystallized from magmas. And so the one that we found fell right smack in the middle of that window of this ancient zircon population. And so When we determined the age, we said, wow, this thing is old. Therefore, the shock event formed long before it got into the meteorite. So this thing most likely dates from the earliest history of Mars in terms of when the shock event was.
Can you narrow down where on Mars it probably formed? Because you've got obviously a very old crater and then a relatively young one, a very recent one.
Okay, you're asking all the right questions, and I'm just going to have to be upfront and say on some of these specifics, we're just going to have to punt for now. Here's what we know versus what we don't know. What we do know is that this zircon formed before it got into the material that ultimately became Black Beauty. We know the zircon crystallized at 4.45 billion years ago. Therefore, the shock event had to come sometime after that crystallization age. It could have been, 10 minutes later, or it could have been several hundred millions of years later. And right now, the answer to that is not known, principally because the event that produces the twins in zircon, we haven't been able to date precisely. And so we don't know when the impact event occurred. We also don't know how big the impact event that made those shock twins in the zircon was. And I'm talking about like the size of the crater that likely was formed. Here's what we do know about that subject of size. On Earth, the three largest impact events that have been identified, the Frida Fort in South Africa, which is upwards of 300 kilometers in diameter, the largest currently known on Earth. Sudbury in Canada, upwards of around 250 kilometers. And Chicxulub in Mexico, the dinosaur killer, 65 million years ago. That one's 180 kilometers in diameter. And so the three biggest impact structures known on Earth all have many shocked zircons with these kinds of deformation twins preserved in the rocks that have been sampled. My group and others have done a lot of work on these sites to document those kinds of features in zircon. And so we know where they form in craters on Earth. And while we think of those three that I mentioned, including the dinosaur killer at 180 kilometers, while we think of those as big ones, we need to check our size bias at the door. The moon that preserves this early history of bombardment on its surface has impact craters measured in the thousands of kilometers in diameter. So orders of magnitude bigger than anything identified on Earth. And coupled with that, we have shocked twin zircons that have been found in lunar samples as well. So we know that these features are associated with the formation of some of the biggest impact structures known. It's not exactly well constrained how small of an impact you can have to produce this feature, but we know they occur at the big ones. We know early in Mars history there were large craters forming, some many thousands of kilometers in diameter as proposed by others. And so we don't know the exact size or the location of where the crater may have formed to shock the zircon. It's even worse than that. If the concept that this zircon may have formed potentially far from the site where the Black Beauty meteorite material ultimately collected, then the zircon could have been blasted off some far distant remote location in a giant impact or even just a large impact.
Remember, Mars has far less gravity than the Earth, so yeah.
That's correct. It could have been blasted some ways away and been transported to the site of the Black Beauty meteorite material. And so right now, the southern surface of Mars, southern highlands, certainly has quite a few impact craters, and it's sensible to think that it originated in that environment. But I don't feel comfortable throwing a dart on a map at this point to try to pinpoint it further.
That's petrologist Dr. Aaron Kavosi from Curtin University. And this is Space Time. Still to come, the ancient giant supermountain range which may have helped the evolution of life on Earth. And later in the science report, scientists admit they still have no idea what the giant shark megalodon would have looked like. All that and more still to come on Space Time. A new study claims that giant mountain ranges, at least as high as the Himalayas and stretching up to 8,000 kilometres across entire supercontinents, would have played a crucial role in the evolution of early life on Earth. The findings, reported in the journal Earth and Planetary Science Letters, are based on a detailed examination of zircons with low luteum content, a combination of minerals and rare earth elements only found in the basements of high mountain ranges, where they form under intense pressure. The research by scientists at the Australian National University found that these super mountain ranges only formed twice in Earth's history. The first, between 1.8 and 2 billion years ago, has been named the Lunar Supermountain, and it coincides with the likely appearance of eukaryotes, organisms with specialized components in their cells that would eventually give rise to plants and animals. The second, between about 500 and 650 million years ago, has been named the Transgondwanian Supermountain, and it coincides with the appearance of the first large animals. That was around 575 million years ago, and the Cambrian explosion 45 million years later, when the most animal groups appeared in the fossil record. The authors say that as the supermountains eroded, they would have provided essential nutrients like phosphorus and iron to the oceans, supercharging biological cycles and driving evolution to greater complexity. The supermountains may also have boosted oxygen levels in the atmosphere needed for complex life to breathe. This is Space Time. And time now to take a brief look at some of the other stories making news in science this week with a science report. Scientists have found evidence of some level of natural immunity in unvaccinated people up to 20 months after contracting COVID-19. The findings, reported in the Journal of the American Medical Association, looked for antibodies against the part of the virus that binds to the receptor in human cells. They found that people with a confirmed COVID-19 infection but who were unvaccinated still had these antibodies as much as 20 months after getting the virus. However, the authors didn't assess whether these antibodies were able to actually neutralize the virus. So they can't say if people remain protected against further infection for that long, especially when it came to emerging variants. So far, more than 5.8 million people have been killed by the COVID-19 coronavirus since it first spread out of Wuhan, China. However, the World Health Organization says the true death toll is likely to be at least double that amount, with almost 400 million confirmed cases globally. A new study warns that the intensity of ocean heat waves and the number of days each year they're likely to occur are both expected to increase. Large marine ecosystems account for 95% of global fisheries catches, but previous climate models haven't looked at this sort of ecosystem scale. With sea temperatures expected to generally rise under climate change, researchers look specifically at the impact of heat waves above this background long-term trend. A report in the journal Nature Climate Change shows that the intensity in annual days of ocean heat waves will be larger over most large marine ecosystems, and that these heat waves pose a serious threat even if the species living there could adapt to the background long-term warming. Scientists say that despite all the publicity, stories and movies, they still have no real idea what the giant shark Megalodon would have looked like. In the past, most scientific depictions of Megalodon suggest that it was a scaled-up version of the modern-day great white shark Carcharodon carcharias, the white pointer. That is based on the shape of Megalodon's teeth. Shark species are often identified by their teeth, and white pointers have large triangular teeth with serrated edges, and so too did Megalodon, only 3 times bigger. So, because white pointers average between 5 and 7 metres in length, their Megalodon ancestors would have been around 15 to 21 metres long. For the record, the largest white pointer ever seen was some 36 feet, that's 12 metres in length, which would have meant that Megalodon could reach an astounding 36 metres in length, as big as a blue whale. Now, all this sounds fine and dandy, but as scientists studied Megalodon teeth more closely, they found significant structural differences compared to the teeth of white pointers. White pointers belong to a family of sharks called laminids, which are partially warm-blooded. And while Megalodon may also have been warm-blooded based simply on the size of the animal, scientists have now determined that they belong to a different family, and so may have appeared quite different in appearance. The findings, reported in the journal Historical Biology, suggest that there's still a chance that Megalodon could have been similar to the white pointer in appearance. After all, most sharks do look sort of alike. But for now at least, the truth remains a mystery. and a nightmare from below as you enjoy a swim at the beach this summer. And taking the award for the silliest story of the week has to be the 30-year-old actor Demi Lovato, who says quite proudly that she likes singing to ghosts help them overcome trauma caused by sexism. Tim Mendham from Australian Skeptics says it's all part of her efforts to push a new paranormal documentary series.
Demi Lovato is the American singer, young pop singer, etc., who was apparently going on a bit of a hunt for UFOs and ETs, star people, as some people refer to them as. Certainly she did. And they went into one particular house, which was supposedly haunted, etc., and they came across a spirit, which was a bit amorphous type spirit, and the machine that they had with them let off a noise. These machines always do, and they're always interpreted as sort of saying something or being a reaction to something. People always do say that. They're pretty dodgy machines half the time, and they will go off in response to all sorts of stuff. Anyway, it was sort of going, making little noises and then stopped. And then Demi Lovato, in her wisdom, decided that, would you rather if the men that are with me left the room? And once they did, she gets another noise. And then she says she figures out that, are you a star person? So it's not a UFO, no, it's a ghost, etc. But she figures out that with little responses to buzzers and clicks and things that she's getting, that this ghost was subject to trauma, sexual abuse, or God knows what else. And therefore, the men who were outside the room, obviously listening in, said, sing her a song. So I don't know if this ghost could hear them suggesting that, but anyway, she did. She sang a song called Skyscraper, which was apparently a hit of hers. I don't know it, I must admit. And after the song was over, she got what she figured was a standing ovation. If you wonder if ghosts stand or need to.
How do they even clap?
I don't know. Well, the machine made a noise, basically.
Oh.
And the story goes, the three of them took it as a sign of a standing ovation. And Demi Lovato was really thrilled by that, getting a standing ovation. I don't know how often she gets one. But anyway, so this sort of little story about her, which is part of a documentary series, really. So there's certainly a level of publicity involved in this. Got a lot of retweets and things like that. She said even though they're originally setting out to search for UFOs and ETs, they came across a ghost who had suffered sexual abuse and was really upset at sort of having men in the room.
Well, the ghost was living in an old brothel, wasn't she?
Something like that, yeah.
Jim?
A place called Vulture City, which is, apparently this was an old brothel, which was sort of, I don't know what they were doing in a brothel looking for ETs, but I hate to think.
It's been a long journey.
They're on R&R. Yes. So anyway, they use this EMF detector, which is electromagnetic detector, and which are notorious for just clicking off at all sorts of signals that they pick up. It could be from a mobile phone in your pocket. It could be from something else outside.
EMF
It could be
detector. That means a radio, doesn't it, to you and me?
Pretty much, yeah. A radio that clicks, right, when it picks up a signal. And they are really unreliable, almost as unreliable as lie detector machines. So anything that indicates that I'm communicating with a ghost via clicks on an EMF machine is sort of, it just ends up being the silliest story of the week, really.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel. And on Facebook, just go to facebook.com/spacetime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.